A rectangle is a parallelogram. It's a special type of parallelogram. So we're getting more specific. So we started with parallelograms and now we're zooming into a specific type of parallelogram. So it's a parallelogram with 4 congruent angles. All 4 angles are right angles. So it's a parallelogram. So the opposite sides are congruent. Both pairs of opposite sides are congruent. All of its angles are right angles. So all of the properties of a parallelogram are still going to apply to a rectangle. So all of those rules about opposite angles being congruent, consecutive angles being supplementary, the diagonals bisecting each other, opposite sides being congruent, all of those properties still apply to this rectangle. But there's one new special property about a rectangle. One of the new special properties is that its diagonals are congruent. So not only are the diagonals bisecting each other, that's still true because it's still a parallelogram, but they're all going to be congruent. So that means they're going to chop each other in half. But since they're equal to each other, all of these little nuggets are all going to be equal as well. So this piece, this piece, this piece, and this piece are all congruent. This whole entire diagonal is going to be congruent to this whole entire diagonal in a rectangle. Okay, so in this example, let's say RSTU is a rectangle. Should have told you that. Alright, so if RST is a rectangle and RZ is 3x plus 8 and ZS is 6x minus 28, well, we just learned that in a rectangle the diagonals bisect each other and the diagonals are congruent. So all of these little halves are going to be equal to each other, are going to be congruent, so we can just set RZ and ZS equal to each other. So we can say that 3x plus 8 should be equal to 6x minus 28, and so I'm just going to solve for x. I'm going to subtract 3x from both sides and then add 28 to both sides to get 36 equals 3x. Divide by 3, x is 12, but read the problem. It doesn't say find x, it says find uz. So I'm going to go take the 3 and plug it in. Doesn't matter to which one because they're going to be equal to each other. So I'll plug it in for RZ. RZ is 3 times 3 plus 8, which is 17. So RZ is 17, ZT is 17, UZ is 17, and ZS is 17. So UZ is 17. And you can double check it by plugging the 12. So x is 12, but make sure you go back and read the problem. It doesn't say find x, it says find uz. So what we're going to have to do is take your 12 and plug it back into one of these expressions for x. So it doesn't actually matter which one I'm plugging it back into because they are congruent. So I'm going to plug it into RZ. 3 times 12 plus 8 is 44. So RZ is 44, ZS is 44, ZT is 44, and so is UZ. They're all congruent to each other because in a rectangle the diagonals are congruent, and so when they bisect each other all of those halves are also going to be congruent to each other. Cool. Okay, so in the rectangle above, RS is 12, RT is 13. So I'm going to redraw this rectangle. RS is 12, RT, which is the diagonal, is 13. It says find ST. Well, we know that the angles in a rectangle are right angles. So, oh my gosh, I have a little right triangle. I can use Pythagorean theorem, a squared plus b squared equals c squared, 12 squared plus x squared equals my hypotenuse, which is 13 squared. And this ends up being a Pythagorean triple. So you actually don't have to show this work if you recognize it's a triple, but 12 squared is 144, 13 squared is 169, so I subtract 144 and get 25. And then I take the square root of 25 and get 5. And it's plus or minus 5, but since it's x is representing the length of a side, it can't be negative, so ST is 5.